Okay, here we've got the classic hanging spring problem. So a weight hanging from a spring is stretched 5 units beyond its rest position and released to bob up and down. Its position at any time t is s equals 5 cosine t. What are the velocity and acceleration at time t? Describe its motion. So they're telling us the position is the s. So we just take from that s, our position, as s equals 5 cosine t. So velocity is the derivative of position. So velocity then is going to be 5 and then times the derivative of the cosine, which is negative sine t. So velocity is going to be negative 5 sine t. And then acceleration is the derivative of velocity. Okay, so acceleration is equal to negative 5 times the derivative of the sine, which is the cosine. Okay, so here is your position function, velocity function, acceleration function. And so what does this tell us about the motion? Well, the position is 5 cosine t, so position is going to look something like, this may not be super exact, but it's going to look something like this. Cosine, we're going to start up here at 5. We're going to go down here to negative 5. It's a cosine function. So it looks something like this. And then what we're going to do is we can graph the velocity from that. So we'll do velocity in this pink color, and it's the sine now, but it follows right along with the cosine. So it's going to have this sort of shape. Again, that might not be 100% exact, but it's going to be very close. So here's my velocity. It's a negative velocity, then positive, and then negative again. And then just remember with the with our spring, what we're doing is we've got this weight, some weight, and we've stretched the weight on a spring to 5 units off of its normal. So we would say if this would be 0, this would be up 5. So here we are at negative 5. Okay, so this weight is going to bounce up and down. All right, and it gives us then all these things. So we can look at these two graphs and determine all kinds of different things. It's got its maximum velocity, when that weight is up here at 5. So when it's zipping back up, it's at its maximum velocity. It's at its lowest velocity when it's on its way down. And so we can just put all of that together to kind of get an idea of what's going on. The speed of the weight is always the absolute value of the velocity. So if we wanted to know what the speed of the weight was at any time, we can just pick that time interval out, place it into t, and take the absolute value. When t is 0, the speed of the weight is 0, and as the weight reaches its different maximum points, it freezes before it changes direction. So at those times it's freezing, it's going to have no speed or velocity at all. The acceleration is always the exact opposite of position, okay, because you're, the way that you would move. So when the weight is above the rest position, the gravity is going to pull your weight back down. And when the weight is below rest position, the spring is going to pull it back up. So all these things are happening on this one problem. And what's the biggest thing? The biggest thing is if I asked you what the position was or velocity or acceleration at a specific time, you could tell me that by substituting in whatever value we are interested in right here for t. And then we would know what our position, velocity, or speed,